to covalent bonding, which can be of three types. Okay, non-polar, polar covalent bonding, and coordinate covalent bonding. Okay, now let's see a small example. Let's take an apple. Okay, we can cut it. Supposing my friend is just there and both of us are hungry, then what do? We cut it equally. Okay, and I give half to her and half to me. So what am I doing? There is equal sharing of this apple. The same thing happens with electrons. There could be equal sharing. That only results in non-polar covalent bonding. So the word equal sharing is important. Okay, the same apple, I am hungry, my friend is also hungry, but supposing I am stronger and I am more hungry, what would I do? I would say, hey, come on, let's share this apple with each other, we both are hungry. But what do? I cut it like this such that the bigger piece comes to me and the smaller piece goes to my friend. Now what am I doing? It is unequal sharing. Okay, see there it was equal. Here the bigger piece is there and this is a smaller piece. This also is being shared, but it is shared unequally. Okay, so this would result in polar covalent bonding. So that means this is unequal sharing. Okay, we will come to this later because sharing comes from one element and that is called coordinate covalent bonding. Now let us move on to non-polar covalent bonding, that is equal sharing of electrons with some examples. Okay, first one that we see usually when we come to covalent bonding, this always happens with non-metals, with non-metallic elements. When we saw ionic bonds, it was between a metal and a non-metal, whereas here it's mostly always between non-metallic elements. And if their electronegativity will be almost similar, okay, there will not be a large difference in their electronegativities, okay, that only will result in covalent bonding. Okay, so when we go to non-metallic elements, let us take hydrogen as an example. Examples, okay, and the first thing that we are going to see is non-polar covalent compounds. That means they will be resulting due to equal sharing of electrons. Okay, the first example is hydrogen. Usually when we write hydrogen, we don't write it as H, but it's always H2 because two atoms make up one molecule of hydrogen. In other words, hydrogen is diatomic in nature. Okay, so how do you get this H2? How is that bonding formed? That is by non-polar covalent bonding. See, let us take hydrogen. There is only atomic number 1, which means there is only one electron in itself. Okay, let us take one more hydrogen atom that also has only one. It is like supposing I have a chemistry textbook and my friend has a physics textbook. I don't have physics, she doesn't have chemistry textbook. Then we decide to share both these books among each other. So I share my book with her and she shares her book with me. That is how a non-polar covalent bonding is formed. Okay, so now these two combine together, then this would result in these two electrons coming together like this. Okay, now there is a bond that is formed between the two hydrogen atoms, and for the bond between these elements in the covalent compounds, it is represented by a dash. Okay, and always we should remember one thing: for one pair of electron shared, if one pair of electron is shared, it results in one covalent bond, a single covalent bond, and it is represented by a single dash. Results in a single covalent bond. This is very important. Okay. So here again, this is only one pair. See here, there is only one pair that is being shared. So when only one pair is shared, there is only a single covalent bond, and this is given as hydrogen, that is H2. This is how hydrogen molecule is formed. Similarly, when we come to chlorine, chlorine also is diatomic, which means it is made up of two atoms. So we write it as Cl2. Now, when two non-metallic elements of chlorine are combining, the atomic number being 17, it is 2, 8, 7. So there are 7 valence electrons. So let's do it. Supposing we take chlorine here, and another chlorine is also reacting with it. This has 7. This atom also has 7 electrons. So they combine together. So what happens? These two electrons will share with each other. That becomes common to both the chlorine atoms. Now what happens as a result of this? This chlorine atom has 8 electrons. This chlorine atom also has 8 electrons. So both of them tend to obey the octet rule and they become stable. Now how many pairs are there in the center? Common to each other is only one. So we write it like this, that is Cl2. This is how chlorine molecule is formed. Now let's go on to oxygen. Oxygen also we write as O2. How do we get that? Oxygen's atomic number is 8, which means the electronic configuration is 2, 6. Okay? Each atom of oxygen needs 2 electrons. So what does it do? It shares its 2 electrons with another oxygen atom, and that atom shares 2 electrons with this oxygen atom. Let us see that here. Oxygen here with 6 electrons. Okay. Now this reacts with another oxygen atom. This also has 6 electrons. So if they want to be stable, they have to share with each other between the two oxygen atoms. There are 2 pairs that are being shared. Now this is common to both. Both of them can enjoy this. It belongs to both of them. Then it becomes 8 for this oxygen atom and 8 for this oxygen atom. But remember, 2 pairs are being shared. Here there is only one pair. Here there is only one pair. But here there are 2 pairs being shared. That results in a double bond between the 2 oxygen atoms. But of course we represent it as O2. There we don't know, but then it is a double covalent bond. It's a double covalent bond. Okay. Now let's move on to the next example of nitrogen. This is represented, the atomic number is 7. So the electronic configuration would be 2, 5. How do we write this? Let us see nitrogen. It is running short by 3 electrons to obey the octet rule. Therefore, 2 nitrogen atoms, when they combine, they need to share more. Okay, when they are running short, they have to share more. Okay, see, when a person has 4 rooms and there are 4 people, they don't have to share much. But when there is a single room and 4 people have to be there, they have to share a lot of things. Okay, similar to that here, there are 3 things that they need to share with each other. Here also there are 3 electrons that needed to be shared. So, when they are bonding, they bond this way. How many pairs are being shared? There are 3 pairs. Okay, because of 3 pairs, there would be a triple bond. This is a triple covalent bond. Okay, this again is represented as N2. That is fine. But this is how the electron dot structure goes for a single, a double covalent and a triple covalent bond. Of course, there are 2 more examples that we need to see which don't come under double or triple, but it comes under the single ones. The 5th example is methane. Methane's formula is CH4, which means it has 1 carbon atom and with 4 electrons in the outermost shell. See, the atomic number is 6, which means the electronic configuration is 2, 4. That if it has to be stable, if it has to obey the octet rule, it needs 4 more. And having 4, it's not easy to lose, neither is it easy to gain. Both are difficult. So sharing is the only option left. So what does it do? It shares with 4 hydrogen atoms to form a compound of methane. Okay, hydrogen has an atomic number 1. Now let's see the electron dot structure. Let us take carbon with 4 electrons on 4 sides. Needs 4 more. Now let us take hydrogen. Okay, this has 1 here. And another hydrogen with 1 electron, 1 more hydrogen and another here. So when these are into sharing, each of these hydrogen atom gets 2 and the carbon atom as a result gets 8. Okay, so as a result it goes this way. Okay, now if you see here, there is only 1 pair that is being shared. Therefore, only 1 bond will be formed between the hydrogen and carbon atoms this way. This is represented as CH4. This is the methane molecule. Okay. Now the last one is carbon tetrachloride. from the word there is one carbon atom and tetra means 4 chlorine atoms combined together. The last one is carbon tetrachloride. Okay, now let us take carbon with atomic number 6, which means electronic configuration is 2, 4. Let us take chlorine atom with atomic number 17. The electronic configuration would be 2, 8, 7. See, you can either write it this way or you can write 2, 8, 7 in KLM. Both ways are okay. Whatever it may be, now we have this carbon atom in the center with 4 electrons and it needs to share with 4 more elements. And we have a chlorine atom here, another chlorine atom here, another chlorine atom and a 4th one here. Okay. Now these 4 chlorine atoms have 7 electrons in the outermost shell. Each one would have 7. Okay, so they need one more to become stable. So how does this go about? Let us do this carbon here with 4 and this chlorine atom's carbon electron comes here. So it makes up a total of 8 for each of the chlorine atoms and a total of 8 is there for the carbon atom also. See, 1, 2, 3, 4, 5, 6, 7, 8. So there is 8 for each of the carbon atom and the chlorine atoms. Thereby it results in, now if you see here, the shared pair of electrons, there is only one shared pair of electron between the carbon and each chlorine atom. Therefore, we represent it by 1 dash, that means it is a single covalent bond. Okay, this only is written as CCl4. Okay, so actually we should remember that CCl4 has 4 single covalent bonds. There is a difference. These are all single covalent bonds because one pair is being shared, whereas nitrogen molecule has a triple covalent bond. This is different, this is single, but there are 4 single covalent bonds. Okay, this much about the covalent bonds. We'll go into the coordinate bonding shortly.